January 15, 1991, 2200 hours, Iraqi Air Defense Operations Center, Baghdad. Major General Muzahim Saab Hassan stood in the underground command bunker, watching the Kari system's glowing displays paint Iraq's airspace in phosphorescent green. Around him, 36 radar operators monitored screens showing what Western analysts called the most sophisticated air defense network outside Moscow. The displays were hypnotic. Concentric circles radiating from Baghdad showed overlapping coverage zones, SA-2 and SA-3 missile batteries at long range, SA-6 and SA-8 systems at medium altitudes, ZSU-23-4 Shilka guns for anything that got through, 7,000 anti-aircraft guns, 16,000 surface-to-air missiles, 478 early warning radars. Hassan watched a training exercise unfold on the screens, simulated American aircraft approaching from Saudi Arabia. The Kari system, built by French contractors and named for Iraq spelled backwards, tracked each target flawlessly. When simulated missiles launched, the computer calculated intercepts with precision measured in meters. General, his intelligence officer approached with a folder marked Coalition Air Capabilities. American reconnaissance suggests they may attempt strikes within 48 hours. Hassan opened the report. Satellite photos of F-15s and F-16s at Saudi bases, performance specifications he'd memorized, maximum speed, radar signatures, weapons payloads. At the back, a single page marked Classification Speculative. F-117, stealth fighter, unconfirmed capabilities. U.S. propaganda suggests reduced radar signature. Assessment. Physically impossible. Radar cross-section cannot be meaningfully reduced below aircraft physical size. Hassan closed the folder and smiled. His staff had discussed these rumors for months. American magazines published artists' renderings of angular black aircraft that supposedly defeated radar. Iraqi intelligence had examined the claims and reached unanimous conclusions. Stealth is a myth, Hassan told his officer. Electromagnetic waves don't lie. Metal reflects radar. Our systems see everything from cruise missiles to small aircraft. If the Americans come, we'll see them 200 kilometers away and destroy them 100 kilometers from Baghdad. Outside, the city slept under clear January skies. Hassan's network hummed with power, data flowing through fiber optic cables to sector operations centers in Taji, Kirkuk, H3, and Talil. Each sector could track 120 aircraft simultaneously, coordinating missile batteries without activating their own radars, making them invisible to American radar-hunting missiles. The math was comforting. Even if 10% of Iraqi missiles found targets, the Americans would lose hundreds of aircraft. No Air Force could sustain such losses. They would try precision strikes, maybe special forces raids, but sustained bombing of Baghdad? Impossible. Hassan had read the intelligence assessments from the 1973 Yom Kippur War, when Egyptian SA-6 missiles had shocked Israeli pilots accustomed to air superiority. Iraq's defenses were 3 times as dense. Baghdad was protected by 65% of Iraq's SAMs and more than half its anti-aircraft guns. "Sir," a radar operator called out, "exercise complete. All simulated targets intercepted or forced to disengage." Hassan nodded. The American deadline was 36 hours away. The United Nations ultimatum for Iraq to withdraw from Kuwait. Saddam Hussein had no intention of complying. War was coming. Let them come, Hassan thought. Let them send their F-15s and their B-52s and their carrier aircraft. Let them even send these phantom stealth planes that supposedly bend physics. The radars will see them, the missiles will find them, and Baghdad will remain untouched. In the display room's fluorescent glow, Hassan couldn't have imagined that in 38 hours, his entire command network would be in ruins, destroyed by aircraft his radars never saw. The Americans weren't coming with physics as Iraq understood it. They were coming with physics Iraq didn't know existed. If you're fascinated by how American ingenuity changed warfare overnight, hit that like button. And if you think you know which U.S. military innovation was even more decisive than stealth, drop it in the comments. Subscribe so you don't miss how American engineering repeatedly shocked the world. The confidence Hassan felt that January night wasn't arrogance. It was calculation based on the best military science of 1990. The CARI system was designed by Thomson CSF, the same French contractor that built NATO's air defenses. It divided Iraq into 4 defensive sectors, each with a sector operations center that could track 120 aircraft simultaneously and coordinate responses across hundreds of square miles. Below the SOCs, 25 intercept operations centers coordinated individual batteries. The system could automatically target SA-2 and SA-3 missiles without those batteries activating their own radars, making them invisible to American Wild Weasel radar-hunting aircraft. Baghdad alone was protected by 3,000 anti-aircraft guns ranging from 23mm to 100mm caliber, 60 SAM batteries including SA-2, SA-3, SA-6, SA-8, and French Roland systems, 154 acquisition radars, and integrated fire control linking everything into a single coordinated defense. The numbers were staggering compared to historical benchmarks. Hanoi during the Vietnam War, the most heavily defended city in that conflict, had faced American aircraft with roughly 1/3 Baghdad's defensive density. The North Vietnamese had shot down hundreds of American planes. Baghdad's defenses were 3 times stronger. Iraqi intelligence had examined American stealth claims systematically. Their analysis, circulated to senior commanders in December 1990, was dismissive. American propaganda suggests aircraft with reduced radar signatures. Technical assessment, impossible. Radar cross-section is determined by physical size and material composition. No known material can reduce reflection below 10% of aircraft dimensions. Conclusion: psychological warfare designed to intimidate, not operational capability. They were wrong about everything. Iraq's confidence stemmed from 8 years of war with Iran. Iraqi air defenses had shot down hundreds of Iranian aircraft using these same systems. They knew their radars worked. They'd upgraded continuously, adding French Roland missiles, Soviet SA-8s, improving radar integration with each year of combat experience. What they didn't know, what they couldn't have known, was that American engineers had spent 15 years solving a problem Iraqi military science considered unsolvable, making radar itself useless. The story began in 1975, not in Baghdad but in Burbank, California, at a secretive facility called the Skunk Works. Lockheed engineers Bill Schroeder and Dennis Overholser were working on a problem that had frustrated aircraft designers since radar was invented. Every attempt to reduce an aircraft's radar signature involved making it smaller, using special materials, or adding electronic countermeasures. Nothing worked well enough. Then, Schroeder had an insight. What if you didn't try to absorb radar energy, but reflected it away from the source? What if you broke the aircraft's surface into flat panels, each angled to bounce radar signals anywhere except back to the receiver? Using a Cray supercomputer, cutting-edge technology in 1975, Overholser developed a program that could calculate how radar waves would scatter off complex geometric shapes. They called it ECHO, and it predicted something extraordinary. An aircraft made entirely of flat-angled surfaces could scatter 99% of incoming radar energy away from its source. The prototype they built was so angular, so faceted, so geometrically impossible looking that Lockheed engineers called it the hopeless diamond. It looked like a stealth fighter designed by someone who'd never seen an airplane. When they tested it at a radar range in 1977, Pentagon observers were skeptical. "Aircraft don't work like that," they said. "Aerodynamics require curves, smooth surfaces, streamlined shapes." But when they turned on the radar, the hopeless diamond disappeared. The radar cross-section was smaller than the pole it was mounted on. American engineers had achieved the impossible. They'd made an aircraft, a real, flyable, weapons-carrying aircraft, effectively invisible to radar. The program that followed was called Have Blue, then Senior Trend, then finally designated the F-117 Nighthawk. Development was conducted in absolute secrecy. Components were ordered using false addresses. Equipment was rerouted from other programs. Workers didn't know what they were building. Test flights happened only at night at remote bases. The first F-117 flew in 1981. Initial operating capability was achieved in October 1983. For 5 years, the aircraft remained classified. The American public didn't know it existed. Neither did Iraq. By January 1991, 42 F-117 Nighthawks were operational with the 37th Tactical Fighter Wing, recently deployed to a remote Saudi base called Khamis Mushait, 650 miles south of Baghdad. As January 16th dawned, coalition aircraft began their pre-strike rituals at Saudi bases. F-15s, F-16s, F-A-18s, all visible on radar, all part of the expected attack. But at Khamis Mushait, 42 American pilots walked toward aircraft that broke every rule of aerodynamics Iraq had ever studied. The F-117 looked like it had been assembled from triangular panels by an engineer with a protractor and no sense of aesthetics. Faceted surfaces at odd angles, no curves anywhere except the wing edges, engines buried deep inside the airframe, exhausts flattened to horizontal slits. It was ugly. Maximum speed, 646 mph, subsonic. It couldn't dogfight, couldn't outrun interceptors, couldn't survive a turning battle with a 1960s-era MiG-21, but it could do something no aircraft in history had ever done. It could make radar lie. January 17, 1991, or 038 hours Baghdad time, 30 miles inside Iraq. Task Force Normandy, 8 AH-64 Apache helicopters guided by 4 MH-53 Pave-Low helicopters opened fire on 2 Iraqi early warning radar sites codenamed Nebraska and Oklahoma. 27 Hellfire missiles streaked through the darkness. 170mm rockets followed. 4,000 rounds of 30mm cannon fire shredded the radar installations. The attack lasted exactly 4 minutes. When the smoke cleared, a 30-kilometer corridor existed in Iraq's radar coverage, a deliberate gap in the electromagnetic fence that had protected Iraq's airspace. But in Baghdad, Hassan's command center saw nothing unusual. Radar coverage was redundant by design. 2 sites going offline could mean technical failures, scheduled maintenance, power fluctuations. The Kari system showed no penetration, no threat. They didn't know the corridor was deliberate. They didn't know what was coming through it. 16 F-15E Strike Eagles followed, hitting the local Air Defense Command Center with precision-guided munitions. Behind them came 3 EF-111 Ravens, their jamming pods creating electronic chaos across Iraqi frequencies. And behind them, flying alone through the darkness at 20,000 feet, came the real threat. At 0251 hours, Major Gregory A. Fest's F-117 released the first bomb of Operation Desert Storm. Inside Feast's cockpit, 15,000 feet above Iraqi desert. The heads-up display showed targeting data streaming from the aircraft's infrared acquisition system. No active radar. The F-117 carried no emissions that enemy receivers could detect. Navigation was inertial, updated by GPS satellites Iraq didn't know were tracking their every move. Targeting was purely passive, using heat signatures and a laser designator invisible to Iraqi warning systems. Below, an Iraqi Air Force interceptor operations center. From this bunker, controllers coordinated MiG-29 and Mirage F-1 fighters across southwestern Iraq. Destroying it would blind an entire sector of Iraqi air defenses. Fest's weapons bay doors opened, a 3-second window of vulnerability as the internal bay briefly exposed metal surfaces. A GBU-27 Paveway 3 laser-guided bomb dropped free, its guidance fins adjusting microseconds after release as the laser painted the target from 15,000 feet away. The bomb fell for 14 seconds. Impact velocity, 1 in 200 feet per second. Penetration depth, 4 feet of reinforced concrete. Detonation, inside the bunker's operations room. The IOC ceased to exist in a millisecond of superheated destruction. So did the link between Iraqi border radars and Baghdad command. A critical node in the Kari network simply stopped functioning. In Baghdad, Hassan's command center saw nothing. No radar track, no missile launch warning, no electronic signature, just an IOC that stopped reporting. Then another one went dark, then another, then another. What Hassan didn't see, 10 F-117s from Khamis Mushait, flying single-ship missions separated by precisely calculated minutes, systematically destroying the nodes that held Iraq's defense network together. Each F-117 carried 2 2,000-pound GBU-27s. Each bomb was guided with precision measured in feet, not yards. Each target was carefully selected not just to destroy, but to blind. to remove Iraq's ability to see the conventional strike packages that would follow. At 0300 hours, H hour, the designated start of Desert Storm, another F-117 pilot positioned his crosshairs over a telecommunications center in downtown Baghdad. The AT&T building, American planners called it. The structure controlled civilian and military communications across central Iraq. The bomb fell. The building exploded in a fireball that lit the night sky. And Baghdad's air defenses erupted into chaos. SA-2 missiles launched from sites across the city, their rocket motors drawing orange lines against the black sky. SA-3s followed. SA-6s tried to acquire targets that didn't exist. Anti-aircraft guns opened fire, creating streams of tracer fire that arced into empty sky. They were shooting at nothing. The Americans had done what physics said was impossible. They had made a bomber invisible. The science behind the F-117's stealth wasn't magic. It was geometry and materials science pushed to extremes that Iraqi engineers couldn't comprehend. In 1975, when Lockheed Skunk Works engineers began the stealth program, they discovered something revolutionary. Radar worked by sending electromagnetic pulses and measuring reflections. A curved surface, like every aircraft ever built, reflects some energy back to the receiver no matter the angle of approach. But flat panels, precisely angled, act like mirrors reflecting light away from your eyes. If you broke an aircraft's surface into flat panels arranged at specific angles, you could scatter 99% of all incoming radar energy away from the source, sending it anywhere except back to the radar receiver. The F-117's entire airframe consisted of 78 individual flat surfaces, each calculated by supercomputer to deflect radar at angles where no receiver would be positioned. It looked faceted, angular, aerodynamically impossible, because 1975 computer technology could only calculate radar cross-sections for flat surfaces, not the complex curves that would come later with the B-2 and F-22. But it worked, spectacularly. Radar cross-section, the measure of how detectable an aircraft appears to radar. B-52 bomber, 100 square meters, visible on radar from 300 miles away. F-15 fighter, 25 square meters. MiG-29, 15 square meters. F-117, Nighthawk, 0.01 to 0.03 square meters. To put that in perspective, the F-117 appeared on radar as a target smaller than most birds. A pigeon has a radar cross-section of approximately 0.01 square meters. The F-117 was one-tenth the size of a pigeon on Iraqi radar screens. But the fastening was only half the equation. The entire aircraft was covered in radar-absorbent material, a classified composite of magnetic iron particles held in polymer binder that absorbed radar energy instead of reflecting it. The RAM coating alone weighed nearly 1 ton and required 126 maintenance hours for every flight hour to keep functional. The exhaust was redesigned into horizontal slits to hide the engine's hot turbine blades from infrared sensors. The weapons bay was fully internal. Any external stores would have destroyed the stealth characteristics. Even the cockpit canopy was coated with conductive material to prevent radar from bouncing off the pilot's helmet. The result was aerodynamically unstable in all 3 axes. The F-117 couldn't fly without constant computer assistance, a quadruple redundant fly-by-wire system making thousands of tiny adjustments per second to keep the aircraft controllable. Performance specifications told the story of compromise: maximum speed, 646 km/h subsonic, combat radius, 600 miles without refueling, service ceiling, 43,000 feet, maneuverability, poor, survivability in a dogfight, essentially 0, but survivability against the most heavily defended airspace on Earth, 100%. That first night, Iraqi radar operators stared at screens showing empty sky while explosions ripped through downtown Baghdad. Some thought their equipment had malfunctioned. Others thought the Americans had developed energy weapons, striking from space or with directed energy lasers. The truth was simpler and more devastating. American engineers had made an entire generation of air defense systems obsolete. Inside the Baghdad Air Defense Operations Center, 0310 hours. Hassan stared at his displays with confusion, rapidly becoming horror. "Sir, Sector 2 reports multiple strikes, no radar contacts. Talil IOC is offline, no Mayday transmission, no warning." The AT&T building just exploded. No aircraft on approach vector. The CARI system's greatest strength was its integration. Every radar fed data to the sector operations centers, every SOC reported to Baghdad. The network was designed for redundancy. If one node failed, others compensated automatically. But the network wasn't failing randomly. It was being decapitated systematically. F-117s were hitting the nodes themselves, command bunkers, communications hubs, relay stations. "Launch missiles," Hassan ordered. "Saturate the known approach vectors." SA-2 batteries began firing. Obsolete Soviet missiles from the 1960s, upgraded with newer electronics, but fundamentally unchanged since Vietnam. Their launch plumes lit the night sky in orange fury. They were firing blind. No radar tracks, no target coordinates, no guidance data. Just shooting into emptiness, hoping to hit something, anything. Anti-aircraft guns joined the chaos. The doctrine was brutal. If you can't see the enemy, create a wall of lead they have to fly through. ZSU-23-4. Shilka Systems pumped 23mm rounds at 3,400 rounds per minute. S-60-57mm guns added heavier fire. The sky over Baghdad became a steel storm. Tracer rounds created streams of light visible for miles. SAM exhausts drew orange lines. High explosive shells burst into white flowers of destruction. Not a single F-117 was touched. The American pilots, flying through this maelstrom, reported surreal scenes, watching the city light up below them like a fireworks display, seeing missiles launch and curve away toward empty sky, flying through flak bursts that never came close because the gunners were aiming at ghosts. Captain James R. Masney, on his third mission over downtown Baghdad, later recalled, "The intensity was beyond description. They had an endless supply of ammunition and they were using all of it. But they were shooting at where they thought we were, not where we actually were. I watched an SA-3 launch and knew immediately it wasn't tracking me. It was heading for empty sky 2 miles to my left." The first night numbers told a story that would reshape military thinking for the next 3 decades. F-117 sorties flown, 43. Targets struck, 31 command and control facilities. Radar contacts achieved by Iraqi defense network, 0. F-117s damaged by enemy fire, 0. Iraqi SAMs fired, estimated 200. Iraqi AAA rounds expended, estimated 20,000 plays. Hits on F-117s, 0. Coalition losses that night from all causes, 2 aircraft, neither of them F-117s. Iraqi air defense network degradation after 12 hours, 40%. The Americans had sent 42 stealth fighters, representing 2% of total coalition aircraft, to strike 31% of first-night strategic targets, and the Iraqis never saw them coming. The pattern repeated for a week, each night bringing fresh devastation. F-117s flew exclusively at night, each on single-ship missions, timed to arrive over targets minutes apart. Day 2, 44 sorties. Targets, ammunition bunkers, chemical facilities, Iraqi fighters launched. But found nothing. F-117 losses, 0. Day 3, 42 sorties. Baghdad Central ADOC destroyed. Coordination collapsed. F-117 losses, 0. Days 4-7. Average 40 sorties daily. Bridges, power stations, Scud storage. Iraqi pilots refusing missions. F-117 losses, 0. By January 23rd, F-117, 280 sorties, 142 targets destroyed, 80% success rate, 0 losses. Iraqi air defense, 65% degradation, 38 fighters lost, 47 SAM sites destroyed. After the ceasefire, American interrogators questioned captured Iraqi officers. Their testimony revealed complete psychological devastation. Lieutenant Colonel Tariq Hamid, SA-6 battery commander, "We fired 22 missiles the first night, clear acquisitions on radar, every missile guided to intercept, every missile exploded in empty air. We checked systems for 3 days, nothing wrong. The Americans weren't where radar said. How do you fight when your instruments lie?" An Iraqi Air Force officer, "The worst part wasn't bombing. We expected that. The worst part was helplessness. We had 16,000 missiles, 7,000 guns, 478 radars, and couldn't stop 42 aircraft, not because they overwhelmed us, but because they made our system irrelevant. We were blind." A MiG-29 pilot who defected Command sent us on intercepts. We flew where ground control calculated. Our radar showed nothing. Empty sky. After 4 missions with 0 contacts, I refused. Half my squadron did the same. What was the point? Chasing ghosts. The captured Iraqi intelligence assessments revealed wild speculation, electronic warfare beyond known technology, satellite weapons, plasma shields, none correct. From Iraqi military assessment, March 1991. American stealth technology proved operational. Previous intelligence declaring reduced radar signature impossible were incorrect. Battlefield analysis confirms 99% plus radar cross-section reduction. Soviet-era defense systems unable to provide effective detection. Recommendation: Western air defense doctrine requires complete revision. The admission represented complete reversal, acknowledgement that American engineering had leaped so far ahead that Iraqi strategy was obsolete. The F-117's success fundamentally altered military thinking worldwide. Russia accelerated programs producing the Su-57. China began research leading to the J-20. European nations initiated projects with reduced signatures. American programs accelerated. The B-2 Spirit received increased priority. The F-22 Raptor was fast-tracked. The F-35 Lightning II included stealth as baseline. Technology evolved. The F-117's faceted design gave way to smooth curves as supercomputers calculated complex reflections. F-22 Raptor, 0.001 M2 radar cross-section 10 times better. F-35 Lightning II, comparable with modern curves. B-2 Spirit, 1 M2 on vastly larger platform, but the principle remained: scatter radar away, absorb what you can't scatter, minimize emissions. Desert Storm lessons endure in American doctrine. First, technology can render defenses obsolete overnight. Iraq's $11 billion defense investment, 15 years of work, neutralized in 72 hours by 42 aircraft. Second, psychological impact matters as much as physical destruction. Iraqi defenders feared F-117s more than any platform. Stealth panic caused missile conservation, radar shutdowns, defensive paralysis. Third, integration multiplies effectiveness. F-117 wasn't invincible. Yugoslavia shot one down in 1999. But combined with jamming, defense suppression, conventional strikes, stealth became overwhelming. When the U.S. returned to Iraq in 2003, F-117s again struck opening targets. This time, Iraqi defenses barely responded. Commanders learned resistance meant destruction. Stealth broke Iraqi will before ground forces crossed borders. Modern air defense, Russian S-400, Chinese HQ-9, can detect some stealth under specific conditions. But detection doesn't guarantee engagement. The F-117 demonstrated even with warning, if aircraft are too fast or gone before missiles arrive, detection is useless. Total Desert Storm F-117 statistics: aircraft deployed, 42 initially, 50 by war's end. Total sorties, 1,980. Targets struck, 1,969. Combat losses, 0 battle damage, 0 coalition context. Total aircraft, 2,250. F-117 percentage, 1.8%. First day targets by F-117s, 31%. Iraqi degradation. Original missiles, 16,000 missiles fired, 4,000 plus. Shootdowns, 38, 0.95% success. Network destruction, 80% Vietnam comparison, 1965-1973. SA-2s fired, 5 to 800 U.S. losses, 110. Success, 1.9% Desert Storm, 1991. SAMs fired, 4,000, losses 38. Success, 0.95%. The difference was technology. American aviation advanced 20 years. Iraqi defenses remained frozen in 1973. At the National Museum of the U.S. Air Force in Dayton, Ohio, an F-117 sits in retirement. Its black faceted skin looks ancient and futuristic, how 1970s technology predicted modern warfare. The placard lists: RCS Ivoporo 3 M2, 1,271 sorties, 0 losses. The display case contains radar-absorbent material, a targeting pod, and a quote from an Iraqi officer, 1995. We laughed when intelligence mentioned invisible aircraft. We dismissed American stealth as propaganda, impossible physics. How can metal not reflect radar? Then, January 17th, we stopped laughing. Our screens showed empty sky while Baghdad exploded. F-15s we could track, F-16s we could engage, but stealth bombers, we called them jinn, spirits. They struck 43 days. We never saw one on radar, not once. After ceasefire, American officers showed gun camera footage. We watched bombs fall on buildings we'd sworn to defend. We saw our missile launches from their perspective, trails of fire curving into darkness, chasing nothing. That's when I understood. We hadn't lost to a better military. We'd lost to a different century. Americans fought with 1990s technology. We defended with 1960s systems. The gap was unbridgeable. You didn't build a better bomber. You built a bomber our worldview couldn't comprehend. We prepared for aircraft. You sent ghosts. The F-117 program began in 1975 as Have Blue, a demonstrator Pentagon officials thought impossible. The first prototype flew in 1977, so unstable it required constant computer assistance. Cost $656 billion over 15 years. Expensive, controversial, questioned. Iraqi generals mocked the concept. Baghdad radio ridiculed imaginary invisible planes. Those imaginary planes destroyed Iraq's command infrastructure in 72 hours. They flew 1,280 sorties without loss. They proved American investment in breakthrough technology could deliver capabilities, rendering enemy defenses obsolete. The lesson wasn't about stealth specifically. It was about the danger of assuming your enemy's limitations match yours. Iraqi planners used Soviet doctrine, Soviet equipment, Soviet assumptions. They believed stealth was propaganda. American engineers rewrote the rules. When Baghdad's sky lit with anti-aircraft fire, January 17th, Iraqi gunners shot at phantoms. Real threats were invisible, untouchable, unstoppable. Precision bombers rendering defensive preparation meaningless, turning billions in Soviet missiles into scrap. Saddam's generals laughed at stealth aircraft, dismissed it as fantasy, mocked it as impossible. By February, they weren't laughing. They were surrendering to an enemy they never saw, never tracked, never touched. They were learning American ingenuity, American engineering, American willingness to pursue the impossible, had created weapons from the future, fighting defenses from the past. The final count, 42 F-117 Nighthawks, initially deployed 1,280 combat sorties over 43 days, 1,969 targets, struck with precision measured in feet, 0 combat losses, 0 battle damage. Against the most heavily defended airspace in the world outside Moscow. Every sortie returned, every pilot came home, every mission demonstrated American technological superiority over Soviet defensive doctrine that Iraq had bet everything on. The invisible had won. American technology triumphed. Modern warfare would never be the same. The ghosts of Baghdad proved the future belongs to nations willing to invest in it, to innovate beyond what seems possible. To believe impossible is just another engineering challenge waiting to be solved by American ingenuity. Iraq believed stealth couldn't exist. Their Soviet advisors said it violated physics. Their radar operators trusted their instruments. Their generals mocked American claims as propaganda designed to intimidate rather than reality. America made it real. American engineers solved problems Iraqi science deemed unsolvable. American pilots flew missions Iraqi defenses couldn't stop. American technology rendered Soviet doctrine obsolete overnight. And that made all the difference in who controlled the skies and who won the war.